hear the end of our conversation if they so like.
That's fine. We can
Oh,
invite all of our many viewers to come join our server.
all three viewers. We were just talking about, for context, for those of you who might be joined in, of reliving the glory days of when we used to play lots of Minecraft by starting up a Minecraft server again and having fun. It's so weird to think, when did Minecraft come out? Like 2008, 2009? I first
We
played it on
we
the.
were at uni and we
I
played
played.
like one of the first alphas.
I remember playing it on the free weekend when it came out because his Notch's PayPal, like very early on, it got super popular and his PayPal got frozen. But
Yeah,
that was it, 2 million or 20 million bucks in it.
yeah,
It
it was
was one of
something
those
like
two.
that. It earned like an insane amount of money in 24 hours, and PayPal blocked the account. Yeah,
Yeah, and
and then it
then
was just free.
that was when
Hey,
I
Mark.
remembered started playing it. Submark.
Yeah, we are
Uh,
old.
man, like, and just I don't know, just randomly the other day I was like, I want to do it again.
It's funny
Yeah,
to say, like when people ask me what's the game you've probably got the most hours in, I still have to say
Minecraft.
Minecraft. Yeah.
Yeah, Mark, we're only old because you're also old. I mean, come on, you can't talk.
Yeah, this is true.
And also, if you, I mean, I don't know if anyone's been paying attention, but it may have been like 3 weeks, 2 or 3 weeks.
Three. This is week 4.
Yeah, where we weren't streaming because of like just stuff. So work stuff, life stuff. So we're today we're going to consider this a cash, relaxed, laid back episode. We are going to do a bit. We're going to do a little bit more of the CTF that we've been
We're
picking our way
basically
through.
going to progress to where we're up to because it's not much further than where we left the last stream because of all the
Yeah,
stuff that's happened.
but we're going to be more relaxed about it. Oh, hey, Benjamin Franklin.
You can't talk either. You were part of all of this from the start.
Yeah, we were thinking of us. Unless you've just tuned in, we were thinking of starting a Minecraft server again. Would you be in?
Would you be
And
in?
I know this is like meant to be like a security like CTF slash like infosec kind of tools and how to do stuff stream, but we're just talking about Minecraft. Oh, because I was thinking about starting up a server, so get back to me on that one. Um, anyway, uh, so yeah, this is going to be a bit more cash, a bit more relaxed. We haven't really prepped. It's been a few weeks since. Well, actually, no, we did look at this stuff last Monday. We just didn't end up streaming
We
last
just didn't do
last
anything on
Tuesday.
it.
So
Yeah.
uh, maybe this will help actually create a better stream because I find some of our best ones are the ones where we just have no expectations.
This is true. Yeah.
Yeah, definitely not much has changed. Oh, you know us too well. Straight to the heart, my friend. Straight to the
Uh,
heart. I'm honored that you still remember me and you know me. To anyone who's watching this who doesn't know us personally, you're just mystified with these two random dudes in the conversation we're talking to. We know them. We don't know you, but feel free to talk
feel free to
or
talk.
chat.
We'd like to know you.
Yeah.
Do that update.
Oh, he thinks he can rope his missus into it.
Oh, nice.
No, I appreciate you never had expectations for me, Mark. Makes life easier. Never let anyone ever set expectations for you. Anyway, let's get started.
Let's get started. So, what do I need to do? This transition. There we go.
Uh,
So where we left off last time was roughly we got access to this. Hang on, let me full screen this so it looks nice. We got access to this control panel with some creds that we brute forced guessed the pin for. We took a little poke around on the box and we discovered I can't remember the name of the binary, but it used this shared object library.
yeah.
And
So
we spoke about how in the past we've done some exploits with shared object libraries that we're going to sort of follow on now.
So for context, on Linux, you've got your
It was
binary,
PingSec
which is
D.
the same as Windows. You might have your exe file, right? And then on Linux, you've got your SO or shared
Yeah,
object
okay.
files. They're similar to DLLs on Windows. The way you can compile an application, you can either dynamically link or statically link. So dynamic linking is you've got your binary. It only has the code you wrote in it and some other stuff whacked in by the compiler, and then effectively references out to DLLs or SO files on the operating system that do specific functionality. So you could update the version of those DLLs to fix bugs or add functionality or whatever. And as long as the method signatures are still there and they do the same thing, it all works. Static linking is where you pull in all the code from those libraries into your code. I think you have to do that from source, though. You can't statically link in a DLL or a SO
Not
file.
a runtime.
No, you need to do it with headers and stuff like that.
It's when you build it and your binary becomes a lot larger because they're all bundled into the one binary rather than linked at runtime.
On the plus side, less system dependency, so more portability. On the downside, like I think there was that problem with like some GDI years and years ago now, where it was statically linked in so many places that they all had the same GDI. Was it Ghost? The Ghost vulnerability? It's like 6 or 7 years ago now. I'm going back a long time.
It's history.
Back in the early days of named vulnerabilities. Anyway, continue.
So yeah, we found this PingSecD binary with a sticky bit for PingSec management. So we figured that's the next step. We decompiled this already a little bit last stream, and that's where we figured that it uses this libpingsec.so, except I just did a boo-boo. And so now we are going to try and compile our own that can turn us into PingSec management instead.
For context on the server, the libpingsec.so file had read-write permissions to the world.
Yeah, I think. Yeah, because when I booted up to have a look, mine was in my home directory, but I don't think that's right. I think it was. Where was it?
Just do a. I did a find. Just do a find for it.
Oops, except I've done that wrong already. I did a find slash.
Oh, good.
Dash name that.
And then
but it's there.
Ton of errors.
It's in slash lib.
Yeah.
So I basically, because we've got global read write to it, I just copied it to my local home directory so I could copy it easily to my local machine, and now we can analyze it a little bit. I think we already analyzed it and identified everything.
I think I'd opened it up in Ghidra.
You opened it up in Ghidra, and we found that there's 3 functions.
Yeah, 3 functions that do nothing because it's a dummy file. Most of these CTFs, when they do have this sort of thing, it's a dummy file that you then, or dummy functions that you basically implement, but you implement maliciousness. And because of the way dynamic linking works, all we need to do is then put our malicious version of this SO over the original one, and when it gets called, it picks up the method signature and runs our code.
Yeah. So basically what we're going to do is, actually it's source code, so I'll make it .c, create our own bad version of it that is going to, like you said, we have to replicate the same functions that it called. So it had these 3, opt-in, opt, and banner. And basically what we're doing is the opt-in is doing nothing, pretty much. The opt is doing nothing, and our banner is setting some user ID and group IDs, which we're not doing 00 because this is not, when we go back to our PingSecD, it's running as PingSec management, not as root. So we need to duplicate the user ID and group ID of the user that owns it. Basically, that's where we got those numbers from, and then we're telling it to run bash.
So it can be easy if you're used to following tutorials or looking at CTFs that jump to root to just assume you always do 00, but you can assume other user IDs, and sticky bits can allow things to run as other users who aren't root. it's not all exclusive to root. Like the assumption might be from most of what you see talked about and what you see in CTF. So this PinkSec one has many sideways kind of lateral moves before you actually get to any level of privilege. So this is just another one of those steps.
It's got a lot of common, like things you might find commonly in a lot of CTFs that are just default. Like you said, by default, a lot of them are always just 0 for the user and group and things like that. But in these, they've changed it slightly, so you have to actually, I guess, learn or understand them more than you normally would, which I like. I like that about these. You can't just copy paste from what you did in a previous box. So now all we're doing, we know that Pinky's Palace is a 32-bit, so we're compiling it in 32-bit. I think if you get an error, which I did the first time because I'm on 64-bit Kali, you can install the GCC multilib stuff, which allows you to compile in 32-bit. And then we're pretty much just saying output, compile this C that we just copy pasted in and compile it to this file, which is and the -shared is compile it as a shared object library, not as a binary directly.
I will say as well, the C we copy pasted it in was from our Confluence, so we
wrote
it.
Yeah, this is stuff that we wrote.
Well, I say we wrote it. It's the basic level of basic that anyone would write something that looks like that.
So if I the bad.so.c. So just looking at it again. So basically, whenever you do one of these, those 3 lines will be exactly the same every time, except like we said, sometimes those numbers will change. The only thing that's different is the other functions. If a lot of the time there are no other functions, so you only have to copy one, but in this case we just had to copy 3 and just make them do nothing. And our way of making them do nothing is set x to 1.
I mean, they're called in that order, I think, as well. So I suppose we could have just done PS opt-in and none of the others, and it might have worked, but
doesn't matter. That has a void in as a parameter, and the others don't.
No,
I don't remember.
That's fine. It takes a void in the Actually, I think we copied the function names and signatures straight from the Ghidra decompile. So I say we wrote it. We barely even wrote it. We took decompiled.
We pretty much added that and that. Oh yeah, was the x equals 1 already in there?
No, I think we added
it already
there was issues.
It did something.
There was issues with them empty.
Yeah, it did something dumb that was basically the same thing. So now what we're going to do is, if I can remember how SCP works, I think I go this, the pinksec bad.so to pinksec at 1.148 to the home, and you have to do full pathing. Actually, I'll just do temp because I don't actually care. Now, if I go back to my machine and head over to temp, I should have our, let's just ignore those for now. We have our bad compiled shared object library, which now it's easy to just copy to my home directory. Cool. You're with me?
I'm with you, sorry.
Nice.
I was just looking at a meme someone sent me, sorry.
Oh, we are professional.
I've been getting into political memes, like not the politics that's going on in the moment, but like political ideology memes.
Okay.
So purely because of the entertainment value and just laughing at the world.
Fair enough.
Yeah.
So now, now all that's left to do is to replace the existing libpixenc.so with our bad one. And because we've got global read write, we can just copy it straight over the top. .bad.so to /libpinksec.so. Boom.
And we should be good to go.
Now, when we go to our binary, which is here, and go to run it. I think you have to pass this on an argument, don't you?
No? Oh, yeah, you do. Doesn't really matter.
And looking at it now, we are pink sec. Yay! That didn't work. So we can tell it ran bash. It did not give us...
Oh, because you have to make it run sh, I think.
Run.
If you do,
Oh, no. Yeah. Yeah, it has to be .sh, not bash.
So this is what we found when we did
That's right.
is bash is really good at dropping privileges it doesn't like.
So it basically has been told to
well, because if you do an ID once we get into sh, it'll show you the user URI, which is just your normal user ID, and then it's got EUID, which is your extended or elevated user ID. I think the E stands for either one of those two.
Effective, isn't
it? Yeah, or effective, the third option. And so SH will happily follow along with that and give you the permissions of that user, but because of all of the vulnerabilities around sticky bits and elevating privilege, Vim's another great example. These days, modern Vim, I think, and VI just refuse to pick up sticky bit permissions. So you can't just go rogue and edit a bunch of files that you shouldn't be able to edit.
What am I doing?
So in this
I
case,
don't want here, but anyway, it doesn't matter.
In this case, we need to go for a crapper shell.
Yeah,
SH throws a pain in the ass, and as we'll shortly see, elevating above, getting out of SH proves a bit of a pain.
What am I doing? Let's just do this. There
we go.
Yeah, so now we can see. So in bash, it was essentially ignoring the sticky bit, but in SH it doesn't.
Do you do ID? Yeah, there you go. See, you've got EUID.
Yeah, which I'm pretty sure is effective user ID.
And not everything follows that model. So you can see, we try and open bash. If you try and open bash in this, it doesn't work. If you try and use Python PTY, which I think Jake will do at some point soon, that doesn't work either, because you get back an error about not enough,
there's too many bash something. It's been too long, I can't remember. Out of PTY devices or something, like there's too many PTYs, or I don't know, something like that. We can run it and see what happens. Actually, let's just do it. So here's one I prepared earlier, so I don't have to type it all out. But yeah, you can basically see that we get a weird OS error that we're out of PTYs. And I think when we looked it up, what was it? There's 20,000 or 40,000 allowed PTY devices by default, or something ridiculous.
Yeah, something's been done to break this.
So there's something been done on purpose to make it so that the standard way of upgrading your shell doesn't work.
The actual solution was, though, this was where we copied over the SSH keys, right?
Yeah, so we realized that there's been SSH on this box from the start, and rather than deal with our SOCAT shells, which have actually been surprisingly good, we ended up just dumping some SSH keys on the box.
What I do like about the Pinky's Palace boxes, and definitely this one, is at no stage is anything like so insanely esoteric that it's impossible. Yeah, but it's just all these little twists on standard things. So, because like you hack the boxes and stuff, you tend to focus so much on getting to a good shell so that you can do useful stuff, and you end up getting caught in that pattern. And then sometimes it's just as simple as dropping in an SSH key. and you're away.
Yeah, exactly. No, I called it. Those guys. And then it's PinkSec management. That. So I don't think we ran through generating the SSH keys last time, but basically it was just SSH. That's not the one I wanted you to remember. Keygen. And you give it a name, and that's the file name that it'll create, and then you just enter through a bunch of times, and it'll create a public and private key with no password.
Yeah, so it'll create a .pub file, and then that name without an extension. The one without the extension is the private key, and the one with .pub is public key. Yeah, you left out an S in your SSH. I was going to tell you.
In my copy paste.
Yeah.
Echo S. Actually, screw it. Let me just copy paste the whole thing properly. There we go. That's why it didn't work. I'm sure that'll be fine. There we go. Now we're in. Now that I can learn how to copy paste. So looking at our home, I think there is that supposed to be there?
So this is where we're up to, this PSMC CLI.
Yeah, so again, we basically run through the same process again. So we do find perm with a hyphen, 4000, which is our sticky bit search, and then we just dump everything else to dev null. And we see this time that we've got this PSM CCLI binary with the sticky bit that PinkSec management has access to, that PinkSec didn't have access to.
I will fully disclose, I biffed this bit because I was too dumb to remember that if you copy a file over another file, even though they've got write access, the sticky bit disappears.
Yeah.
And I, for some dumb reason, was like, oh, this is just where we compile our own binary and just dump it on there, right?
We can just write our own, yeah.
The absolute second I realized what I'd done, it was straight away. I was like, I'm an idiot. So Jacob hasn't biffed his because it turns out this one's a little bit more, I don't know, I say sophisticated. It's something we've never really done before, which is, I suppose if we go and look at do you have Ghidra on this, Cully?
Not on this, or actually, let me have a look. I've been through so many Kali boxes recently. /opt. I do.
Sweet. Because if you you've got a double slash there, bud.
What do you mean?
No. Oh, dot opt. Yeah, you didn't need a dot on the start of opt.
Oh yeah, right. You only do that if it's straight away.
Yeah.
That one. There we go. Now it'll run properly.
So if we have a look at it in Ghidra, we'll see what's going on, and that tells us our path forwards.
Yeah.
And this is the bit where
I did it with ltrace.
Yeah. And we're at the bit where we've been kind of slowly chipping along a little bit, but in some ways this is an area where we're learning. So there is a specific printf formatting overflow vulnerability. I suppose you could demo that quickly.
Yeah. Man, I've
once you figure out where you need to be.
Yeah, I'm just not in the mindset, but that's my own problem.
We've all been there.
So I haven't copied it into this folder, but basically we do the same thing. We SCP it over, and I'm just going to steal it from somewhere I know it is. PSM CCLI to here. And then if I ltrace it when I run it, we can see that it's running a printf function. We'll do the same in Ghidra. And when we Googled printf vulnerabilities, we came up with this format string,
Yeah.
which is something that we've never done before. And we're trying to, rather than just copy paste what other people sort of do, we're trying to actually learn and understand.
So most buffer overflows that you find in CTFs, even though they're pretty rare, like we've never really stumbled across many except the other Pinkies ones, tend to take advantage of like mem copy or puts or the reading from the buffer or reading from standard in buffer overflows.
Yeah.
Printf has a very interesting one, which is to do with the way the formatting works. So if you're familiar with any type of print function, because I think or printf function, because they all tend to work relatively similarly, you've got a string and you can have special symbols denoted with a percentage sign and then the character. And then after that first string, each additional argument to printf matches up with the element of the same number in the string, so the format string.
Yeah.
However, if you don't specify any additional inputs to printf, so if it's unbalanced and you've got 5 format specifiers in the actual printf and no additional arguments, printf just takes whatever is on the stack. So whatever's on the stack is meant to be the next successive arguments of the function, but if they're missing, so the %x will take the value off the stack and represent it in hex.
So that's just representing it as an 8-digit padded hex. Yeah. But yeah, you can just do x directly to do the
string will go to the memory address pointed to by the thing on the stack, which often means you hit a seg fault pretty quick because they don't point to real memory addresses because their value is not pointers. Unless you know where a pointer is, and then you can target it. H does something similar to X. N tells you how many bytes have been written out, which you can then use to override other values.
Yeah. I'm trying to find the link that I was...
Yeah, there was that like Assertes one. Was that what it was?
This one. So this is the link that sort of goes through... This is the documentation for what all of the different flags are and what they do.
Yeah.
And then the link to the actual exploit we were following is not in the write-up.
So there's what's considered in a bunch of different places when we're looking around as a good reference for the mechanics of these things.
Actually, Code Arcania. That makes...
Yeah, Code Arcania. Yeah, that's the one. So this one... The first example there. So one of the challenges, and this is going to be hard to talk about because it's easier normally to draw out, is if you're aware of how the stack works. So when an application gets its memory space, you've got the heap and the stack. They're actually all the same largely shared memory space. But what happens is on the heap, it grows from the bottom up. And so you've got your text variables, your application runtime memory, your actual code is all on the heap. But then the stack is kind of like you could consider the working memory or the working out for your application. So when you need something, you can just pull it straight off the stack, dump something onto the stack. But that grows down from the top, as well as function return values and all of that on memory addresses. And that grows from the top of the memory space down. The challenge here is what you're taking advantage of is reading stuff off of stack. What makes it as unpredictable is every time you change the input string to printf, the stack changes. And now it gets real difficult to hone in on exactly what you're doing, which is our challenge. Yes. So the first example here makes that easy by doing a string copy into a buffer and then doing the buffer so that you're no longer having to...
Yeah.
Yeah. It effectively removes away the variability, which for like an introductory thing is actually quite good, gets you around the principles, but very quickly it becomes harder if you're actually using the input straight from the stack.
Yeah. And so that's basically where we're up to. We started following this tutorial and then we realized all of that. And now we're up to trying to figure out how to follow it in a way that will work for us.
He does a good job of explaining the mechanics of these things.
This isn't a bad article.
So that effectively the way it works, if you look at that one, if you go down to his one that actually works, because that's still him working it out. So if you find the last one, we can kind of talk through our understanding of it,
Oh,
and
like
that
his
kind of
actual this
back up.
bit.
Yeah, yeah. So effectively, um, what you have to do is pass into the application because what's being passed in is from the like the args. So and they get written to the stack. Is you've got to write in the target memory address you want to jump to and override. You've then got to make sure you have enough characters. So you abuse the way the %x works. If you add numbers in front of it, that's padding. So to take advantage of that maths, the %n thing, um, you can get it to have numbers that equal other memory addresses, and actually start to be able to actually take control. But it's a weird ass way of taking control.
Yeah.
Um, in this case, he's trying to. So what happens
So
is in an
he uses the upper and lower.
of I mean, conceptually, what he's trying to do, if we just skip to that, and maybe as once we've got this down pat, we'll go through the mechanics of it next week, hopefully.
Yeah,
Uh,
definitely.
but effectively, when you disassemble an app, you've got the function calls, and you've got the GOT, the global
Offset
object,
table.
global offset table that says this function call is actually over here. If you can find the global offset table entry for a different function that you want to run, and in this case, he's trying to run system, and then replace that with the puts, I think was what he had and what we have to
Yeah, he
override.
uses puts. We
So
have to overwrite
you can then
something else.
then when you pass that entire string through, because he's got sh semicolon, effectively what happens is he's then passing sh semicolon and then a bunch of garbage to, oh,
System.
and a comment and a hash for comment so that bash
Yeah.
doesn't freak out. But he's effectively then passing that to a shell so that you can pop shell.
Yeah,
Um,
because
but
in his binary, he's calling the memory address of a system command, so he can just run
yeah,
sh directly, which is
yeah.
another thing that we don't necessarily have to be able to do in ours.
We've got puts down below that we can abuse,
Yes.
but we can't we can't exactly do the same thing. I think is what
No.
we've figured out.
No.
But and in terms of the mechanics of what we need to do, we understand now. We're just dealing with every time you change the input string, the stack changes, and whenever the stack changes, all the offsets change. And if you try and account for the offsets changing, the stack changes again, and it's
And
just
then your
weird.
offsets change again, and then you have to, yeah. So that's where we're just sort of in this loop of trying to figure out how to reliably control the
That
stack.
That said, I think part of what we've figured out is if you set yourself up for success with a really complicated, an already long initial string, you give yourself enough wiggle room. So there's another one we looked at where a guide. So probably what we likely have to do is actually inject shellcode onto the stack and jump to where the shellcode is. So override return or the puts function with a memory address which is in the shellcode,
Yeah,
not
so we
not
jump
system.
to where our shellcode is rather than
Yeah,
call system to run a command directly.
which means in our case we just need to incorporate a massive NOP sled as padding that we can shorten or lengthen, but that way we keep the total string the same length so that we don't have to keep farting around with offsets.
Yes, to try and help us keep the stack length the same and everything.
Yeah. So this is what it's like to learn is we sit here and I've already half forgotten it because there's that brief moment where you hold how something works in your head
We've
and then a week.
spent easily like probably 10 hours or so trying to learn this and figure out how we can apply it to this exploit or to this vulnerability. Hello?
Difficult step.
I think I lost
And
internet for a second
oh, let's check everything's still going fine. Yeah. I think the challenge, and I did enough casual poking around just to double check we were going in the right direction with this, and it is because sometimes you can get lost in a rabbit hole, and it is printf that we have to abuse and a printf overflow. It's just nailing exactly how those work. So um, that's the challenge. They're not super. I've never come across them. I mean, maybe they are more common than I think, but most of the time I think people use Asprint, which doesn't have this problem. Um, all it needs to really do is count how many of those symbols were there and then how many arguments were actually given in the function. And if no arguments were given in the function, then don't obey the format, don't process the format string, just print out whatever was there.
Yeah,
Uh,
basically some sort of standard input validation, if you like, for
yeah.
for the app.
This is the reason why printf's bad to use though.
Yes.
Uh,
Yeah.
Difficult to, well, again, for us, we're still trying to figure it out. But if you know what you're doing, this is probably relatively trivial to take advantage of if you know it's there.
And I'm sure once we learn it and figure it out, and because this isn't just a sort of copy paste example, when we come across it again, we'll know exactly what to do and where the issue is and how to exploit it and things like that. So
Yeah,
that's what we're trying. That's the point we're trying to achieve, is where we can just see a printf and go, yep, I know how to do this,
yeah.
rather than have to go, I know that's vulnerable, let me just go copy paste the
Well,
vulnerability and hope it
and
works.
this is why we try to avoid using Metasploit, and this is why when we are using an exploit DB script, we at least read through the script to understand the mechanics of how it works. If it's feasible for us to actually implement the vulnerability ourselves in its entirety, we will.
To yeah,
Some
rewrite it in a way that
yeah,
we
some
can use it.
sometimes the exploit scripts are complicated enough that it's like, oh man, that's a bit painful. We'll still read it and try and understand it, but like I think the one for Drupal that we used involved a bunch of like generating dynamic things on the fly and all that
Yeah,
sort
it
of
did.
stuff.
Yeah,
So um anyway, that's probably that.
that's sort of where we're up to. Yeah.
So thanks for watching. Uh, a bit more relaxed this week. This one we've been chipping away at for a bit. Hopefully we crack it in the next week and we can actually kind of run through it in detail with you next week,
Yeah.
and actually run through how these things are properly constructed. But
We'll have a better understanding and a better explanation on how they work and how we can apply it.
yeah, all good. Have a good one, everyone.
No worries. Sounds good. See ya.